Sir, we'll start with chapter 1. So what we are doing is just recalling what are the things important, like if there is any formula or if there is any conceptual. Um, for example, if this quantity increase, what will happen to this quantity? In reality, what is this quantity? So like that we will discuss. Okay, so this is what is essential for MCQ. We do not need to recall exact definition as such, but we need to understand how each quantity is affected and how questions are asked in this particular topic. That's what we are interested in. Yes, sir. Okay. Okay. So we will start with chapter 1, the physical quantities and unit. Okay. So in 1.1, we do not have any direct formula, but we have to understand. So um, reasonable quantities. So do you remember that they will ask this question? For example, what is volume of a sand grain? What is mass of a human being? What is weight of a human being? Approximately. So whatever this kind of question, so we just have to do it approximately. So we should be more focused on the magnitude, especially the power of 10 rather than the numerical value. You get the idea, sir? Yeah. Yes, the power matters. For example, maybe let's do this volume of sand grain. Okay. No unit, no magnitude is given, no unit is given. So it's just you that you have to figure it out. For example, work this out. How do you find the volume of sand grain? Yeah, of a single sand grain. No, we just need a volume. Why we want to measure mass? If we can find a mass, also if we know the density, but density is not given, right? Okay, for example, yeah. So what would be the shape of sand grain? Cube of each side. So we can take 1 millimeter each side. So we can definitely consider a sand grain will be approximately cube of each side is 1 millimeter. Then find the volume. Hmm. So it's 1 millimeter cube, 1 into 1 into 1 millimeter cube. Okay, sir. So this is actually 1 millimeter cube is very reasonable answer. Only problem is you won't find the options in the millimeter cube. So sometimes they will give in micrometer cube, sometimes they will give in meter cube. So you should be able to convert this back and forth between this meter cube. So yeah, so just take 10 power minus 3 and cube it. So you will get 10 power minus 9 meter cube. So this conversion is very important. Okay. So here is another, okay, lifespan of human in seconds. Just approximation. Very good assumption, 60 years. Uh, mm. Yes. So 60 into 365 days into 24 hours into 60 minutes. Okay. Um, yeah. 1 minute has 60 seconds. So this is how to. So what you will get. Mm. So you will get approximately 10 power 9 seconds. Okay. They will not give you very close values such as 10 power 10 or 10 power 8 second. They will give like 10 power 9 second, 10 power 18 second, 10 power 20 second. Figuring out this 10 power 9 is very important in this one. Is it clear, sir? Yeah. So here is another one. Age of the universe in second. Yes. Okay. Yes. So I think 13.3 billion in years. Yeah, it's 13.8 billion years. Okay. Hmm. So from this, how will you convert into seconds? Super. So we already found how much is okay. So we just have to find how many seconds in 1 year first. Okay, that you can do. Hmm. Or you can have close. Yes. So the detail value will be 13.8 into billion is 10 power 9. So into again this calculation. Yeah. So 365 into 24 into 60 into 60. Okay. So this we already found this one is approximately 10 power 9. If we divide it by 60, we will get 10 power 8. Mm. So if you multiply it by 13.8 into 10 power 9, then we will get approximately 4.35 into 10 power 17 second. Okay. So, so like this, okay, here's one more. Distance in meters of light year of 1 light year in meters. Yes. Yes. So, is it, yeah, okay, okay, please do it. Super. Awesome. So it's 1 year into 3 into 10 power 8. Okay. We already know 1 year is 10 power 7 seconds into 3 into 10 power 8. That's all you have to do. Mm. So you will get how much? Uh, Approximately 10 to the power 15 meters. This is how you have to figure out reasonable estimation. Okay, sir. So they will ask the actual value is 9 into 10 power 15 meters. Okay, sir. So, mm, so the other reasonable quantities that we need. So this is just an example how to calculate largest things or smallest thing. Okay. So it's not literally limited to something. For example, they can ask ratio of mass of proton and mass of electron. Okay, so you do not need to worry, because in the front page you will have mass of the proton and mass of the electron. So if you know, yeah, mass of the proton is 10 power minus 27, mass of the electron is 10 power minus 30. So you will get the ratio of 10 power 3. So mass of the proton is 1000 times heavier than mass of the electron. Okay, so that you can do. For example, here is another one. Distance between Earth and the Sun in meters. Okay, so we know that light takes 8.28 minutes 20 seconds to travel from Earth to Sun. So you can just find what is 8.28 minutes 20 seconds in meter, light year. Similar to light year, you can find light minute and then multiply by 8.2, so that you can. So uh, yeah, yep. The two takeaway we should learn from this topic is, one, we do not need to pay attention to the first digit. That's not very important. Second, it's all reasonable estimate. You just even if, because sometimes people will frustrate over this because no quantity is given, they don't know how to solve this one. It's a reasonable estimation. Be reasonable to your quantity. That's all. Okay. What we can assume that is, they will not give any too close values like competitive exam, this or that. Approximate values only they will give. Okay, so that we can do. So here is another example. List of examples that you can look for. Okay, for example, diameter of atom, wavelength of UV light, wavelength of light, any color. There will be approximately 10 power minus 8 for UV, 10 power minus 7 for visible light. Okay, something like that. Because so we know that blue length is approximately how much? 500, sorry, 600 nanometer or 400 nanometer. So it's 400 into 10 power minus 9. So if you take two zeros and then 10 power minus 9, if you cancel 2, then you will get approximately 10 power minus 7 meter. So this is idea you should get it keep you going. Okay. Height of adult in meter, or mass of hydrogen atom, mass of a human, mass of a car, approximately you can take it as 1000 kilogram. Yeah, so it will be 700, 800 kilogram, depend on the model, but you can, for shape, you can take 10 power 3 kilogram. Okay. So sound, yeah, distance sound can cover in a day. In 1 second, it will travel 300 meter. So same, uh, you get the idea? The same, is it, figure it out. Yes. Ah, yes. Same, like similar to light year, you can also find what is the sound year. So how much sound can travel in 1 year? Yes. So instead of 3 into 10 power 8, we'll just use 330. Then you will get um, approximately 10 power 7. Okay, seconds. Okay, so that you can do. And atmospheric pressure, they will not ask exclusively to find, but it is 1 into 10 power 5 Pascal. Okay, acceleration due to gravity, you know that it is 10 power 1 meter per second square. So radius of Earth is 10 power 6 meter. We know that it is 6,000 kilometer. So it's already, kilometer is 10 power 3. Another 1000, so 10 power 6 meter. Okay. So the idea is, uh, let's say that approximately we want to find a quantity. That is our requirement. We should not pay too much attention to what is the other quantities that we do not know. So take a approximation and move on. That's the idea. So for this alone, for this only we are working. Okay. Yeah. So these are the things. Um, yeah. Okay. So if you want more things when you're free, you can refer this NCRT book. They have this. Yes. Uh, So mass, least mass and heaviest object in the universe, like mass of the universe itself. Uh, I think mass of the universe is 10 power. Hmm, okay. 10. Yeah, we don't, but approximately 10 power 55 or 54 kg. Okay, so just reasonable thing. Okay. Yes, sir. So these are the things. Yes, and so secondly, we have 1.2 SI units. Okay. So remember, we have two things. One is SI unit, another one is SI base unit versus SI base unit. People still misunderstand this one. SI unit is, for example, meter is SI unit for length. Meter is also a base unit, but Newton is SI unit, but Newton is not a SI base unit. SI base unit of Newton is kilogram meter per second square. Similarly, Pascal is SI unit, but Pascal is not SI base unit. So it's force per area. So kilogram meter inverse second power minus 2. So joule is a SI unit, but it's not SI base unit. So joule is force into distance, right? So you will get kilogram meter square second power minus 2. Okay, so this is how we have to work. So if current is SI unit, also current is SI base unit, ampere. So this thing, plus we need to understand this prefixes of pico, nano, micro, milli, centi, deci, kilo, mega, giga, tera. Okay, so this we have to use. Yeah, and you remember this homogeneity of physical equations, whatever the left hand side SI base unit, that should be the right hand side SI base unit. Yes, yes, yes. So that's 1.23 homogeneity. So homogeneity of physical equation. Okay. So whatever the SI base unit left hand side must be the SI base unit right hand side. So this can be SI unit also. Sometimes they'll just ask you, for example, this equation. Okay. Uh, okay. So for example, this is question from so 9702 12 MJ 30. Okay. So second question. Okay. So the units of resistivity expressed in terms of base unit. Okay. So this is symbol for resistivity. This is expressed in terms of this kilogram x power 3, y power minus 2, z power minus 3. Okay. Find what are x, y, z. Do you understand the question, sir? This is unit of resistivity. So how would you find? This is resistivity. Yeah. No, no. You said resistance. Super. Super. Okay, okay. Yes. Yes, yes, yes. Mm. Yeah, yeah. You can do that way. Mm. One minute, sir. Yes, sir. So X will be meter. Mm. Mm. Okay. So what you're telling is B. I'll check. So yes, 12 of S13 MS12. Yes, sir. You're right. Okay. So I just record. Yes, yes. So uh no, no, no. So how do you can find easily is figure out in the terms of formula. For example, what is the formula that you know for resistivity? So resistivity, we know that resistance is rho L by A. So resistivity will be R A divided by L. Okay. So you have to somehow figure out this R in SI base unit or SI unit. So we know that V equal to IR is easy to work. So you can write R equal to V divided by I. But problem is, we know I is SI unit, but V is not. Okay. So what is V? Uh, Energy. Can we call it energy by charge? Hmm. So we know that V is energy by charge into already one I. But Q is not SI unit. So Q, we know that I is Q divided by T. So we can write Q as I into T. So we can write, can you see that? Yeah, sorry, this is R. So we can write R is E divided by, instead of Q, I into T into I. So we can write E divided by I square. So we can work with this E. This is energy, by the way. Okay. So we'll put it in the original formula. Resistivity is R into A divided by L. So, 1 minute, sir. Just 1 minute. Yes, sir. Sorry about that. Yeah. So instead of R, we can write energy divided by I square into area divided by L. Right? So we know that energy is force into distance. So force is kilogram meter into second power minus 2. Distance is another meter. Area is meter square divided by I is ampere square. L is meter. So we can cancel out these 2 meters. So what you will get? Kilogram meter cube second power minus 2 ampere square. Okay. So this we will compare with kilogram, x power 3, y power minus 2, z power minus 3. Z power minus 3. Check if we make any mistake. Z power 3 only. Yeah, here is one more t we missed out. Here is one more t, right? Okay, so you will get second power minus 3. So if we compare this one, then meter cube is x cube. So x is meters. Y power minus 2, ampere power minus 2. So y is A. This one is yes. Okay. So x is meter, y is ampere, and z is second. Super. Okay, sir. This is how you work. So shortest way to do it is directly deal with the formula, because one, it's a less error prone zone. You do not need to work with -1, -2, so you will minimize error. Two, if you do something wrong, you can easily see. Okay. So I'll give one more example on this one. Okay. What is the unit of Young modulus, sir? Quick question. Specification. No, unit. What is the unit of Young modulus? No, you can just tell it. It's Pascal. Okay. So in it will be Newton divided by meter square. Okay. So it's Nm power minus 2. Now work for SI base unit. So it's stress by strain. We know that stress is Pascal. Yes. So how to work is, we know that it is force by area. Force is kilogram meter second power minus 2 divided by area meter square. So what you will get, kilogram meter inverse second power minus 2. That's your SI base unit of Pascal. So this is SI base unit of pressure as well. Okay. Yes. So what you should understand is, if two quantity, they can have same SI base unit, not necessarily they are same quantities. Okay, few quantities they have same SI base unit. That also we have to work out. Okay. So for example, I'll throw this question. Okay. Okay. For example, you know what is a moment of force, right, sir? Yeah. Check. Work for energy and moment of force. Yeah, moment of force, not momentum, moment of force. Let's say that this is a question. You have to check. So two ways you can work. So one, you know that energy is force into distance. So you will work kilogram meter square s power minus 2. So this moment of force is perpendicular distance into force. So also same. Okay. But you do not need to go to this step. As soon as you can see this step, you can arrive the conclusion they have same unit, because this is also force into distance. This is also force into distance. Okay. Yes. Okay. Try this one. Linear momentum and impulse. Yeah. Yes. So linear momentum is mass into velocity. So you have mass kilogram into velocity meter per second. So you have kilogram meter second power minus 1. Okay, sir. Impulse is force into distance time. So kilogram meter into second power minus 2 into second. So you will get kilogram meter second power minus 2. Sorry, minus 1. Okay. So in other words, both share the same unit of Newton second. Newton second. So this is not SI base unit, but SI unit. Okay. Do you understand what we are trying to establish here, sir? Yeah. Okay. Super. Okay. Then we'll do. Try to express unit of power in SI base unit, sir. Super. So we know that power is energy by time. We know energy is force into distance. So kilogram meter square second power minus 2 divided by time is S. So you will get kilogram meter square second power minus 3. Okay. So understand where you are going wrong? Yeah. So this is a very common mistake people do in unit conversion, that instead of adding 1 minus 1, they'll cancel out. So the numerical, this is also possible. So this we have to be careful of. So we have to work in division with full concentration. Yes. Okay. Yes. Okay. Try this one. What is the unit of resistance? So we already figured it out, but as a separate question. SI base unit of resistance. Hmm. Minus 2. Okay. So we know that V equal to IR. So we can write R is V divided by I. So we don't know, we know that V is not SI base unit. So we know that V is energy by charge. So V into Q divided by I. We know that Q is I into T. So E divided by, instead of this Q, I into T. So I square into T. So we know this is joule, that is energy, force into distance. So kilogram meter square second power minus 2 into I square, another here, time here in the division. So second power minus 1 into I square. So ampere power minus 2. Ampere is in the denominator. So you will get kilogram meter power 2 second power minus 3 ampere power minus 2. What do you got? Yes, sir. Okay. Super. Okay, sir. So similarly, you can yeah, yeah. Because we already have one I here. We know that Q is I divided by T. Sorry, I is Q divided by T. So what is Q? That is also right. And then again, this Q is not SI base unit, right? Coulombs is not SI base unit. Only 7 base units are there. Coulombs is not SI base unit. If you give answer in Coulomb, it's wrong. Okay. So only 7 base units are there. I think we have all the 7 base units, right? Yeah. So these are the base units: mass, length, time, current, temperature, amount of substance, and light intensity. So anything else is not a base unit. Okay. Yes, sir. Okay. Yeah. Okay. So I'll see if there is any like very good question that we can struggle, or we can move on from this topic. Mm. Okay. So find the unit of electric. Oh, no, no. This is removed from syllabus, but so is it also work with how if equation is given, you just figure out how to rewrite this equation and find the SI unit. Okay, sir? That is very important. For example, try this question. Okay. So this is 9702 13 ON 15. Okay. Question number 2. So there is some quantity called Reynolds number. So R is rho V capital D divided by mu. Okay, sir. So R is a number. This is a number. Hmm. And rho is density. So V is velocity. So D is diameter. What would be the SI base unit of mu? Yeah, super. R is a number, it doesn't have unit. Super. I think you're close. Yes, sir. I think you're right. Okay. So first thing is we should rewrite this equation. Rho V D divided by R. Okay. R is a number, so we can ignore it. Density is mass by volume. So kilogram meter per minus 3. This is speed. So meter into second per minus 1. D is just distance. So meter. So we will get meter square and meter per minus 3. So you will get kilogram meter per minus 1 and second per minus 1. This is what you got, sir. How you got kg minus 1? Because density is mass divided by volume. So kilogram per meter cube. Hmm. Hmm. No, if you divide it by inverse unit, then you will get everything multiplied again, right, sir? Rearranging is very simple. Hmm. Hmm. Yeah, you get the idea, sir. So you figured out, you established mu here and you figure out what is rho VD. Yes. Okay. Okay, sir. So here is another. Okay. So I'm making up this question. Okay. Yes. So okay, here's an equation. So S equal to A into T plus B divided by C uh, T square. Okay, maybe C plus T. Okay, figure out the units of A, B, and C. No. Okay, C plus X. Okay, leave it. Just have it A by C. So, no, because that lesson. Yes. No, you have to figure it out. How, how this liquid equation looks like. In that, what is S? Displacement. Yes. So you have to figure out what is the unit of A and what is the unit of B. Yes, super. Why they don't have unit? Ah, mm, super. Mm, mm. Yes, yes, yes. Mm. Okay, let's say that A into T, you should have meter. Okay, so we have second. So what is the possible value of A? You will get this one meter per second, then multiply by second. So you will get meter. So A is meter per second. Okay. Okay. So leave the C. Okay. So just as of now, forget about the C. B by C into T square, you should have meter. Okay. So if B and C, if they have same unit, they will just cancel out each other. Okay. So it's not possible. So the combination of B and C is to get meter per second square. No, no, no. Yeah, any combination of these two. In general, what is B by C? What is B divided by C? Acceleration. Okay, leave the number half. It doesn't have unit. Okay, so that's why I want to add here as a T square. Okay, so if I read it, but it will be too obvious that you will figure out. Okay, so so S equal to okay A T plus B by C plus T square into T square. So if C plus T square, then what will be the unit of C? Because we know that only same unit can be added. If C is a quantity can be added with T square, then what is the unit of C? T square. So C will be second square. So B will be meter. A will be meter. You get the idea, sir? Yeah. Okay. So here is another question. This is actual past paper question. Okay. So this one is so 9702 13 October number 15 question number 6. So here is the equation. L into 3 plus a square divided by p equal to q t square sine theta. Okay, sir. Can you see the equation? No, no. Yeah, it's a square. Okay. So a is radius of the tube. P and Q are constant. Okay. So this is angle and L is distance or length. You get the idea, sir? Find units of P and Q. Mhm. Yes, sir. Sin theta will not have any unit. For which is meter per second, sir? Both are. Okay. No? Hmm. Okay. How you got m square by s square? Sir, but you cannot just ignore like that, right? Because it's an addition inside. So what you can do, you could have just take it as 3L plus L into a square by P equal to Q T square. This you can do, but you cannot just ignore the 3, right? Okay. So this entire setup has the unit of this, right, sir? 3L has the unit of meter. So this entire setup should have meter. So L is length, area is, so this is area square. Sorry, area. So meter square. So what you have is meter square in the numerator. Sorry, meter cube. So L into a square divided by capital P, you should have meter. Hmm. This setup you should have meter. Right, sir? So P will be L into A square divided by meter. So meter and meter you can get, then you will get just A square, which is meter square. So remember, we are working like this. L into A square divided by P, the whole thing should have meter. Okay. So if you just want P, you should move this P to the side and meter to this side, right? So you will get P is equal to L into A square divided by meter. So length is also meter, A square is meter square. So you'll get this and this, and you will get meters. Now you don't understand this step. Ah, tell me. Mhm. Yes, yes. No, no. A is length square. Sir, here A is not area. A is length. Can you see radius? Yes. Super. Ah, yeah, yeah. Mm. Okay, sir. So Q and T square, Q T square sine theta should have the unit of length meter. We know that sine theta unit is 1, so we can leave that. So T square is second square. So Q should be length divided by second square. So meter per second square. Okay, so this is how we can work. Okay, sir. Okay, okay, no problem. Okay, if you understand where we went wrong, then we are learning. That's all. Okay. Uh, are you clear, sir? Or do you want more examples on this? Yeah. Okay. Super. So then we will have this errors and answer this question. 1.3. Okay, so we have only two formulas in this one. So one is if this is X and this is Y. Okay. Whether it's X plus Y or X minus Y, then we will add delta X plus delta Y. Okay. If it's X multiplied by Y or X divided by Y, then delta Z by Z is delta X by X plus delta Y by Y. Only these two formulas we need to remember. Okay. Yeah. So in short version, adding two quantities, their uncertainties will be added together. Okay. Yes. So this one. Second, multiplying or dividing two quantities, their percentage of uncertainty will be added together. Yes, sir. Yeah. Okay. So one more thing, but that's not essential. Adding to the significant figures, they don't ask this type of questions in AS and A level physics. But let's say that A has 5 significant figure, B has 3 significant figure. You are doing some combination of A, maybe A square B or A divided by B or A plus B, whatever it is. Okay. If it involves multiplication or division of these two quantities. Okay. So if it is multiplication or division, your answer should have the least SF of all the quantities involved. Do you understand this, sir? For example, in this case, yes. In this case, you should use 3 significant figure. Okay. So if it is addition or subtraction, so you should use least decimal place of all the quantities. Yes. Mm. Yes, sir. Is it clear? Mm. Okay. So finally, this vector and resultant vector. Mm. Okay. So first they will ask resultant vector. So two type of questions they will ask. Just finding the resultant vector. For example, this is A and this is B. We know that this is A plus B. Okay. Sometimes they will give this. If this is A, this is A plus B. What is B? So they will ask like this. So this is B. Okay. And for example, let's say that, yeah, yeah, yeah. Mm. So this is A. Okay. If this is A minus B, what is B? Yep. So this is minus B. So B should be this. Okay. So this is how we should do. Whenever they ask resultant force, okay, for example, so C is the resultant force of A and B. Okay, let's take. So here is A, here is B. Okay, then how A and B should look like? A, B. So this will be C, right on. So as long as it's just resultant force, it will be. Let's say that this is a system in equilibrium and C is a resultant force. So in that case, it will work like this. A, B, this is the resultant force. Okay. If the system is in equilibrium, whatever C, that is the resultant of A and B, are counterbalanced by your resultant force. Opposite direction of the resultant force. Okay. A very good example is, for example, let's say that here is a wall, here is a hinge, here is tension T, here is W. Okay. So they will ask, what is the force acted at the hinge? So first we will find the resultant force of T and W. So here is T, here is W. So you get resultant force like this. Okay. This resultant force must be compensated by the force from the hinge, right? So it should be opposite. So it should act like this in this direction. Okay. So resultant force is different. If the system is in equilibrium, what is the force given by the system is exactly opposite to the resultant force. Then only it can balance and they will result in equilibrium, right? Is that clear, sir? Hmm. Yeah. So that's what we have to learn in. Yep. 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 So resultant force is tail to head. Sorry, any resultant vector is tail to head. But if you are looking for in equilibrium, what force or what velocity should be given so that the system is in equilibrium is you are finding exactly opposite vector to the resultant vector. Hmm. Yes. Yes. That's why if you know the magnitude, you can work with the magnitude. Okay. So this is just general diagram. So what we are doing is without changing the orientation, I'm just moving one on another. That's all. So it will be close. For example, if W is longer, you will have like this. If W is comparatively shorter, you will have like this. This is what you're asking, right, sir? So approximate magnitude only we are okay. Yes, sir. So that's in the chapter one. In chapter one, we don't have formula, sir. We have explanation. That's why it took a little long. All the other so we'll take. Okay. Okay. So we'll wind this today. Yes. I think you have the compiled paper for MCQ I have sent to you. Yes. So work on that one. I'll send the compiled marking scheme also. Okay, sir. So do all the first 6 questions. Those will be belong to first chapter. Yeah. Yes, sir. I'll